Chapter 12, Sound. Sound, a form of energy.
We hear many different types of sounds, ranging from thumping of drums to a note emitted by a flute. When a drum membrane is thumped, it starts vibrating and a sound is produced. The sound reaches our ear and produces a sensation of hearing. Hence, we can define sound as a form of energy which produces a sensation of hearing. In this chapter, we are going to learn how the sound is produced, how it's propagated, and how it produces a sensation of hearing.
Production of sound. Let us try some activities to understand how sound is produced. Activity. Take a tuning fork. Hold its stem and strike the prongs of tuning fork against a hard rubber pad. Now, place the vibrating tuning fork near your ear. You will hear a vibratory sound produced by the prongs of tuning fork. Now, take a pith ball and suspend it by a thread from a rigid support. Strike the tuning fork against a rubber pad and gently touch its prongs to the suspended ball. What do you observe? You observe that the ball is pushed away by the prongs of tuning fork. Why does this happen? Well, this happens because the prongs of tuning fork move to and fro rapidly, due to which sound is produced. This rapid to and fro motion of an object is called as vibrations. This activity shows that the prongs of a sound producing tuning fork start vibrating when struck to a rubber pad. Let us perform another activity with the help of tuning fork. Take a beaker and fill it with water up to the brim. Strike the prongs of tuning fork on a rubber pad. Now, gently touch the surface of water with the prongs of tuning fork. You observe that the prongs splash water. This activity confirms that the prongs of tuning fork vibrates when struck to a rubber pad, producing sound. Now, without striking, gently dip the prongs of tuning fork in water. Do you hear any sound or water splashing? No, it is because the prongs of tuning fork were not struck, due to which the prongs did not vibrate, and hence did not produce sound. We can therefore conclude that sound cannot be produced without a vibrating object. Sound can also be produced by plucking, rubbing, flapping, scratching, or shaking different objects. Here, in each case, sound is produced due to vibrations in the object. Sometimes the vibrations may be strong enough to be seen by eyes, and sometimes so small that can be felt by sense of touch. Flapping of wings by a bird, vibration of strings of a guitar, vibration of a tuning fork when struck on a rubber pad are some examples of vibrations that can be seen through the eyes. Whereas vibration of a mobile phone kept in pocket, vibration of surface of sound box when loud music is played, and vibration of a throat while speaking are the types of vibration that can be felt by touch. Let us now proceed to understand how sound is produced in human beings.
The human beings produce sound with the help of an organ called larynx, which is commonly known as sound box. The larynx contains two ligamentous folds called vocal cords. The vocal cords are stretched across the voice box in such a way that a small passage is created for the air to pass through it. When the lungs force the air to pass through this narrow passage, the vocal cords vibrate, producing sound. There are some sounds produced by musical instruments like flute, violin, veena, etc., which are very pleasant to hear. Musical sound is produced by regular and periodic vibrations. Musical instruments use vibrations of various kinds such as stretched membrane, stretched skin, and air columns to produce musical sound. The musical instruments are thus broadly classified into three categories. They are 1. Stringed instruments, 2. Wind instruments, 3. Percussion instruments.
Propagation of sound.
Let us do an activity to understand the concept of wave. 1. Take a trough full of water and drop a stone in it from some height. What happens when the stone touches the surface of water? At the point of impact of stone with the water, a disturbance is produced. Observe the water surface for some time. You can see waves created at the point of disturbance which move outwards. Now place a small piece of paper on the water surface and drop another stone in water at some distance from the paper. What do you observe? The piece of paper moves up and down, but it does not move with the wave towards the brim. From the activity, we have seen that when a disturbance is produced in a medium, it travels in the medium in the form of waves. Here, the particles of the medium move up or down, and they do not move from one place to other as the wave moves. The medium particles at the point of disturbance vibrating up and down because of the property of the medium make the neighboring particles to follow the up and down motion with certain time lag. This continues and a wave is seen traveling on the surface of the water. Hence, we can say a wave is a disturbance that moves through a medium when particles of the medium set neighboring particles into motion. Thus, wave motion is a mode of transmission of energy through a medium. Now let us understand how the sound propagates through a medium. When tuning fork is set into vibrations by striking it with a rubber pad, the prongs make to and fro movements about their equilibrium position. Let us see in slow motion the movements of the prongs. When the prongs move outward, they push and compress the air layer adjacent to it, creating a region of high pressure or compression. C. As the prongs start moving inwards, they create a region of rarefaction R or low pressure. Due to this, the first layer compresses the layer next to it and undergoes rarefaction. As the prongs move to and fro rapidly in a series of compressions and rarefactions are formed which move in the forward direction. The pressure wave, when reaches our ear, produce a sensation of hearing. Thus, the sound waves propagate through the medium as series of compressions and rarefactions. Sound waves like ripple on the surface of water are called mechanical waves, as they are characterized by the vibration of the medium particles.
Sound needs a medium to travel. Sound needs a medium for propagation and therefore cannot travel through vacuum. Let us perform an activity to demonstrate this. Activity. Take an electric bell and an airtight glass bell jar. The electric bell is suspended inside the glass bell jar. The glass jar is connected to a vacuum pump. Connect the two wires of the bell to an electric battery through a switch. Now, close the switch. Do you hear the sound of the bell? Yes. Now, keep the switch in closed position and start the vacuum pump. What do you notice? Well, you notice that the loudness of bell decreases as the air is taken out from the jar, even though the same current is passing through the circuit. Once the air is fully removed and a vacuum is created inside the jar, you will no longer hear the bell. Let us now understand why does this happen. When the hammer of the bell begins to strike the gong vibrates, due to which sound is produced. These vibrations travel through the air to the wall of the jar. This sets the wall of the jar in vibration, due to which the sound is heard. The sound is heard because of presence of air. But when the vacuum is created inside the jar, vibration could not travel to the wall of jar. Hence, no sound is heard. We can therefore conclude that sound needs a medium to travel. Let us now perform an interesting activity to demonstrate that sound can make a light spot dance. Take a tin can. Make it a hollow cylinder by removing its both ends. Take a balloon and stretch it over one side of the can. Wrap a rubber band around the balloon. Take a small piece of mirror and with the help of glue, stick the mirror to the balloon. Incident light on the mirror fixed on the balloon. You will notice that the light incident on the piece of mirror gets reflected on the wall. Now, shout directly into the other open end of the hollow can.
Hello.
What do you see?
Hello.
Well, you will see the dancing
Hello.
light spot on the wall. Why does this happen?
Hello.
Let us find its reason.
Hello.
When you shout into the open end of can, the sound produced
Hello.
sets the air present inside the can into vibrations. These
Hello.
vibrations in turn cause the balloon to vibrate, due to which the position
Hello.
of light spot keeps on changing. Thus,
Hello.
sound can make a light spot dance.
Sound waves are longitudinal waves. Let us perform an activity to study the direction of vibration to the direction of propagation of waves. Tie one end of a long string to a rigid support such as a wall. Hold the free end of the string in your hand to make it straight. Now, move the free end of the string up and down. What do you observe? You observe that a wave propagates along the strings towards the fixed end. When a wave moves along the strings, particles of the string oscillate up and down about their equilibrium position. Such type of a wave is called as transverse wave. Here the direction of oscillations of the particles of the medium, that is, string here, is perpendicular to the direction of propagation of waves. Let us do one more activity. Have you played with a slinky? Slinky is a very light spring of a long length. Hold one end of the slinky and ask your friend to hold the other end. Now stretch the slinky. Give a sharp push towards your friend. We notice a disturbance traveling along the slinky. Now push and pull your hand alternately. You will observe a series of compressions, C, and rarefactions, R. If you put a dot on the slinky and observe the motion of the dot as the wave travels, you will find the dot oscillates about its equilibrium position in the direction parallel to the direction of the motion of the wave. The waves produced in a slinky are called longitudinal waves. In this type of propagation of waves, the particles of the medium oscillates in the direction parallel to the direction of propagation of waves. Propagation of sound waves through a medium is similar to the motion of disturbance along the slinky. Hence, sound waves are longitudinal waves.